In this video, I will teach you the filter tool and the unique tool. Now these are both found in the data preparation category. So you can see filter here, unique here, and I've made them both favorites. So let's first bring in the data with an input data tool. So the data set I'm going to bring in is on my desktop, and you all have it on Brightspace. So it says ending inventory data set. Let's bring in a browse tool so we can, and let's run the workflow so we can see what our data looks like. So this is the ending inventory for a fictitious wine and spirits retail company as of June 30th, 2016. This is the inventory on hand that they have. And they sell, they're a wine and spirits retailer. They're a liquor store. They're a retailer. So the inventory ID variable tells what store the item is in, what city that store is in, and then the brand number of the item. We have the store variable, the brand number variable, and then the item's description, and then what size bottle we have, how many units of that bottle we have on hand at the end of the month. This is what we charge per, the sales price is what we charge, or the S price is what we charge per bottle. And this is what we pay, the purchase price, the P price is what we pay our supplier to buy each bottle per unit. So what we have here, really the thing that uniquely identifies an item of inventory is the description. So for example, number 3 London Dry Gin, it's brand number 72, but brand number 72, it's it's sold in store 1, which is in Hardersfield, but brand number 72 could also be sold in another store in a different city. So it would be the same inventory. It's the same type of inventory. It's just sold in multiple stores. So that in this data set, the variable that uniquely defines a type of inventory is our description variable. I mean, our brand variable as well. There can't be 2 different brand numbers assigned to this same description. That's true. But just keep in mind, a given brand could be sold across many stores. So what we would like to do is we'd like to take a subset of our data based on some criterion of our choosing. And if that's what you want to do, you use a filter tool to filter our original data here and pull out a subset of data that we want. So suppose we want to know all the items in our inventory for which the purchase price was greater than or equal to $150 per bottle. We would use a filter tool. Now before we use the filter tool, we need to bring in a select tool and change any variable that we're wanting to filter on, like the purchase price variable. If we want to do a numeric sort of operation on that, like a greater than or equal to, less than or equal to, that's not necessarily numeric. You can do that with VString as well, but it's just safe for these variables that really are numeric to just change their data type to numeric. So we're going to change these 3 variables data types to numeric. Now we'll bring in the filter tool. And now the filter tool, you can either do a basic filter or a custom filter. I recommend just doing a custom filter always, since you can do any type of filter with a custom filter, but the basic filter you can only do basic sorts of filters. If you only want to filter on one variable, then you can use a basic filter. But without loss of generality, you can just use a custom filter and generalize to doing any sorts of filters. Now the custom filters, you can see there's a f of x here, so we can type. We have different functions that we could use to filter our data. X, of course, is all the variables in our data set that we can filter on. And then these are our saved expressions, our saved filters. So we can type a filter in here, and then we can save it if it's a filter that we do commonly. We can save it, and then that saved filter will show up here in our folder of saved filters. This also saves our most recent filter expressions. So what we want to do is we want to filter our data where the purchase price is, not the sales price, the purchase price is greater than or equal to $150. So greater than sign, then equal sign, and then a 150. You can add a space between these, that's fine. It doesn't affect things. So what this is going to do is it's going to look in each row of our data set. Each row, and it's going to go to the purchase price column, and it's going to ask the question, is this number greater than or equal to 150? If yes, then this whole row will get output to the true node. If no, then the row will get output to the false node. So let's attach a browse tool to our true node, and let's run. And if we look at the browse tool, we see for each of these rows, the purchase price is greater than $150, greater than or equal to. Suppose we want to further filter this data. We want the purchase price greater than $150, and we want of that which of these units, for which of these items of inventory is the quantity on hand greater than 10. So then we could attach another filter tool to the true node, and we could filter out the rows where the quantity on hand is greater than 10. Attach another browse tool and hit run. And we see here the each row now, the purchase price is greater than 150 or equal to, and the number of units on hand is greater than 10. Notice this right here, it's the same description. This is the same type of inventory, same brand number. It's just, so we have this inventory with this brand number sold in store 1. We have it the same inventory sold in store 2, or 6, I mean, and then store 7 and store 10. But it's the same it's the same type of inventory. So you can see the filter tool, you can do sequential filters. Just keep attaching more filter tools. But a quicker way to do it, let's get rid of this filter in this browse. A quicker way, if we really want, go back to our original data, if we really want all of the items of our inventory where the purchase price is greater than or equal to $150 and the number of units on hand is greater than 10, we can just type all of that in our original filter tool. So you would say purchase price greater than or equal to 150, and then the logical and then on hand greater than 10. So logicals can be included in this filter expression box. Logicals such as and, or. However, it does respect the order of logic. So parentheses and things like that, it reads that correctly. So it reads from left to right unless it sees parentheses, and then it groups accordingly. Just like a calculator does. Excuse me. Just like a calculator does. So now if we run this, we'll see we get the same output that we did after doing, whoops, something happened. Let's run this again. There we go. Now if we run this, we'll get the same output that we did earlier when we just used 2 filter tools. We still get those same records. Purchase price is greater than or equal to 150. Number of units on hand is greater than 10 for each of these. Notice the false node, what goes there, if we go back to our filter, so any row from our original data set where either the purchase price was not greater than or equal to 150 or the number of units on hand was not greater than 10 would go here to the false. So you do have to understand logic when you do the filter tool. So every row here, either the purchase price was less than 150, or the number of units on hand was less than or equal to 10, or both. All right. Now, keep in mind order of logic applies in the filter expression box. So what if we wanted to, all right, let's go back to our original data. What if we want all items of inventory where the purchase price is greater than or equal to 150 and the number of units on hand is either, let's say, greater than 10 or less than 9. Then we have to be careful. If we go here to our filter tool, we can say purchase price greater than or equal to 150 and units on hand greater than 10, or units on hand less than 9. But if we don't put any parentheses in here, it's just going to read from left to right. So it's going to go through a given row. Now keep in mind what we originally wanted. We want all rows where the purchase price is greater than or equal to 150. So that has to happen for us to keep a given row. And the number of units on hand either has to be greater than 10 or has to be less than 9. That's what we want. If we write our filter like this with no parentheses, then we're not going to get what we want. So what it's going to do, it's just going to read from left to right here. So for a given row in our data set right here, it's going to say, is the purchase price greater than or equal to 150? In this row, the answer is no. So it's going to go to the next line. Well, is the number of units on hand greater than 10? Yes, it is. And so that row then will be output to the true node. But we don't want that row output to the true node, right? That's not what we want, because that row, the purchase price, isn't greater than or equal to 150. So to fix this, we have to use parentheses. So we want those rows where the purchase price is greater than or equal to 150 and either this is true or this is true. So if we put the parentheses around this, then what it'll do is it'll read this first. So for a given row, it'll answer this question. Is the units on hand greater than 10 or less than 9? If the answer is no, then it doesn't even move to this condition and the row is output to the false node. If the answer is yes, then it moves to this condition and says, is the purchase price now greater than or equal to 150? If the answer is yes, then the row goes to the true node. If the answer is no, the row goes to the false node. And that's exactly what we want. So order of operations matters in here, just like with your calculator. So now if we run this, every row in the true node the purchase price should be greater than or equal to 150. And the units on hand will be bigger than 10 or less than 9. You'll never see a 9 or 10 here. So what that means is the rows in the false node, the units on hand will be 9 or 10, or the purchase price will be less than 150. So for every row here, the purchase price has got to be less than 150, or the units on hand has to be 9 or 10 if the purchase price is greater than or equal to 150. So you'll see every row satisfies that here in the false node. All right. Let's go back to our output here, and let's talk about the unique tool. So look at our output. So here are all the items, or here are all the rows where our purchase price was greater than 150 and the units on hand were less than 9 and greater than 10. But what if we want to know how many unique items of inventory this represents? Remember, the description is the unique descriptor of an inventory, of a type of inventory. also the brand as well. You know, this type of inventory with this brand number could be in store 1. It could also be, well, it's in store 1, but it also could be in store, you know, one of the other stores as of the end of the month of June 2016. So 910 isn't the answer. That's not how many types of inventory satisfy the condition. We need to find the unique. In other words, this brand might show up elsewhere. It might show up down here. It might be in one of the other stores, right? So we want to find out how many are what are all the unique numbers in this column, or the unique descriptions in this column. So to do that, we attach the unique tool here, the true node, and we just choose which field we want the unique. So we can choose the description field or the brand field, and run. Attach a browse tool. Best practices. So run the workflow. And we look here. Now there's 152 unique types of inventory that satisfy that condition. As you can see there. Now, what if we wanted to further sort this subset of data on, and notice that the duplicates. So what it does is it goes down through, let's look here again to our data to understand how the unique tool works. If we are looking for the unique based on description, it goes through each row, the description field, and the first time it sees a description that it doesn't recognize, like this one, so this row will be output to the unique node. But the next time it sees a row where that is the description, then that row will be output to the duplicate node. Every other row it sees where that's the description, those rows will be output to the duplicate node. So the first time it sees a given description, that row's output to the unique node, and every time after that, the row will be output to the duplicate node. And that's where the duplicates come in. So these are all the duplicates. So for this Aberfeldy single cask, the first time it saw that was right here. So that row is output to the unique node, and then every time after that, the row is output to the duplicate node. And there were a bunch of other rows because this was sold in lots of other stores. Now, what if we wanted to take, let's go back to our original data. What if we want to sort, or not sort, but filter on size? And size is a string variable, right? It's not a numeric variable. We want to filter out, what if we want to know what are all the types of inventory that we sell in a size of, let's say, 1.75 liters. So what are all the types of inventory? We don't care what stores they're in. What are all the types of inventory, the unique types of inventory that we sell in this size? 1.75 liters. Well, then we would need to go attach a filter tool to our data here and filter out where size. Now, since size is a string variable, so we're going to say size equals, we can't just say 1.75 liters. Since size is a string variable, we have to put this in quotes. So when you're filtering on a string variable, you have to put the thing in the particular filter in quotes. So this will pull out all rows from this data set where the size equals 1.75 liters. So let's attach a browse tool here and run and look. So here we go. But there's 21,883 rows, but that's not the number of unique types of inventory for which we sell in this size. because this type of inventory, we might sell it in store 1, we also sell it in store 3, 4, so this appears multiple times in here. So again, we want the unique types of inventory, so we're going to attach a unique tool to the true node, and we're going to get the unique description or brand, either one, doesn't matter, because no two different types of inventory by their descriptions have the same brand number. So the brand number also, we could do it by brand either way. We'll do it by brand this time. And then run. If we look here, so these are the types of inventory. This brand, which is called Rebel Yell, this brand, which is Evan Williams Black Label B, this brand, which is Jack Daniels number 7 Black, and so forth. These are all the types of inventory that we sell in a size of 1.75 liters. It looks like there's 356 of them. All right, so to summarize, you learned 2 tools: the filter tool, which is used to filter on a given data set. You filter on one or more of the variables in that data set to pull out a subset of data from that data set. And then the unique tool you use on a given data set to find for a given variable in that data set the unique values. And it pulls out the first row that it sees for a given value in a given field. And all other rows where it sees the same value in that field, it puts in the duplicate node. And that concludes this video.